Hey guys, this is Mainak, your civil bro. So I'm back with another video. Hope you guys are doing well. What we'll do today is, we will open a project, the AutoCAD file, architectural plan. It is a G+1 building, around 2500 square feet area and 3000 square feet area in the ground floor. So I haven't also watched the plan, properly. So I'll open the plan and all the processes. I'll just do all the things, design in Staad Pro and then detailing in RCDC and the drawing also. I'll just try to demonstrate as much as possible, so that you can also have an idea of how to do the things. This Many of my students are the building consultants, who just need get some tuition for, or get some coaching for, just to clear some of their doubts. So in this YouTube channel also, the effort is that, whatever doubt you might have, if you watch the video and scroll to that particular part, you can clear that particular doubt and maybe learn a few things. Always feel free to just comment and anything which you want to know, and you can drop a like. It really helps out the channel. Okay, so let's see what is with us today. Basically, I'm also seeing this, opening this file in CAD for the first time. I've seen the PDF before taking it. Okay, so I'll open it. So just today I've downloaded this two file, new work. So I think they have given the ground floor and the first floor plan in separate folder, sorry, separate on a CAD file. So this is the ground floor plan. What I want to do is, first of all, I just want to make sure I keep the original copy in the file here, because I'm going to make some changes here. Okay, copy once. Ground floor only I'll be just to make all the things. Okay, so I like black color, so I'll just makes the vision easy, and this one also by layer. Okay, so it makes better view according to me. Okay, so here we have this is the plan here, and this is the what is written first floor. So this is the first floor plan. So let's see the ground floor plan also. I'd rather copy this ground floor plan in this one. Okay, this is the first floor only. I'll open it again. Ground floor plan. Let's see. We'll have the plan description a bit also, just to. So ground floor plan, I'll do the same thing here. 0, it's not this one. First floor plan, copy 0 and 0. Okay. So first floor, this first floor, anything written, area 25,000 square feet, sitting area, store, and in the ground floor we have a car. Okay, now like this you can know, when we have the car, this is the ground floor. Okay, so I'll just copy from here and just select this, and the control plus C. Can also the clipboard, but this is a simpler option according to me. That control plus V and then paste it. Just paste it here. Units are the same, so no need to bother. So now we can close the file and just to work on here. So this is the file which we are working on. And just press Ctrl plus S, NGL copy. This is the file which we're working on. So let's see the plan a little bit before moving on to the structural drawing on the Staad Pro part. So what we have here, you see, this is the ground floor. So the ground floor, okay, the first floor is 2500 square feet. Ground floor maybe a little bit larger, I think. Yeah. So we have a ramp for car parking. This is the parking here, and we are entering through this office area. Okay, entering to this office area. This is the office area, and there is also entry through this carport area. Okay, so this is the this is there is a open hall here, and in the open hall, and there is a living room here. So interesting. So there is a living room here. I have not made the plan. Someone else have. I'm also seeing it for the first time. So there is a toilet here for the living room portion. Okay, if anyone wants to use the living room, that toilet is for that. And this is a common toilet. Okay, this is the attached room. This is a common toilet. Okay, makes sense. And then we have a conference room. Here, office purpose and toilet for the conference room. Then servant room, and then the toilet for the servant room. This is the dining area. This is the kitchen, and then we go to the next floor. Next floor, that is the first floor. In first floor, we have bedroom here, and we have a sitting area, store. Okay, so the person will climb the staircase from here. So this is a lobby. This is a common bathroom and a bedroom here, VIP bedroom. Why this is VIP? I think the size is more. That's why it's VIP bedroom. Okay, so attached bathroom, and then we have another bedroom, another VIP room. Okay, and then this is the sitting area. So the purpose is residential come office purpose. Yeah, okay. So live load will be 2 as per IS 875 part 2. Okay, this is not looking that much commercial purpose, hotel, etc. It can be hotel purpose also, but it's a residential purpose, and conference room is there. Okay, residential come office. So still it will be 2 kilonewton per meter square of live load. And what other information we need? We need the floor to floor height. Okay, so let me count the stairs here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, 13, 14, 15, 16, 17, 18, 19, 20, 20 number of risers. So it should be, if we take, if you are taking 6 inches, or, rather what say in the mm, 150 mm. So 20 into 150, sorry, 20 into 0.15 is equals to 3 meters. So 3 meters is the floor to floor height here, given that they have taken standard riser. So we're going to go with 3 meters here. No problem in that. And let's look at the wall widths here. Usually you can go. Okay, what's at the dimensions? 9-inch wall. Okay, interesting. 9-inch wall here. It depends on the area, because I think this construction is in Bihar. Yeah. So 9-inch bricks are available there. So, or rather you can say 8-inch bricks are available there, and 1 inch maybe for plaster. So that's why it depends. Like in our state, along with plaster it becomes 10 inch. So it depends on area to area what is the size here. And interestingly, they have given the same. There are no half-inch half walls. All walls are the same width. So while we'll apply the load or the member loads, except this portion, toilet portion, we can even bother to give this anyway. This very small distance. We can ignore this particular beam also. So apart from this, all the member loads which we'll consider will be calculated as per this. So once I look, this is the first video. So once I look into the introduction of this project, I'll just write some information here. So which I'll share with you before doing this. So this is a project. I'll just make a simple, maybe a Word file. Maybe open Word. Just open Word document text. Okay, this one. So in this, I'll just try to write some information which we need though. So I'm just covering all the steps because, so name of client, etc. This for this project, we don't know. So purpose will be, residential come office. When I used to work, I just write this down. It's a good habit. This is my style. Residential come office, I think. Yeah. So what can I infer from here? I can infer from here. It is the uh, live load which I'll take. I know live load which I'll take as per right 75 part 2. I'll take 2 kilonewton per meter square. That should be enough. Okay, meter square. And then the next thing which we need is the the member load or the dead load for the wall. So wall load, which is considered in the form of UDL. I have to calculate. And before that, we know floor to floor height is 3 meters. Okay, 3 meters floor to floor height is there. This we know. And the building type, or number of floors is 2, that is G plus 1. So building will be designed for the G plus 1 ground floor and first floor, and the wall thickness is equals to 9 inches, right? 9 inches here. So if you convert exactly 9 inches in 9, this is the calculator. So you can multiply by 25 to calculate approximately. It will be 225. If you do it accurately, it will be 9 into 25.4. It is 228.6. If you do this accurately, 228.6. This is the wall thickness, 228.6 mm. So exactly, if you do this, then this will be 228.6 mm, the wall thickness. So wall load we have to calculate. So in 228.6, yeah, you have this two types of things. There is a brick and the plaster. So this, as per I had said 75 part 1, many videos have shown the load for the red clay bricks is 19 kilonewton per meter cube, and for the mortar or the plaster which you use in between, it's 20. So for the higher side you can consider 20 for both, or you can consider 90. That's kind of an average. You can just take it. So for rough calculation, I'll just take 228.6 or 229, let's say, for calculating the load, multiplied by uh, your this is the wall thickness into height. So this is height is 3 meters, and minimum beam will be this point 0.3. So we'll take height 2.7, 3 minus 0.3, 2.7 meter. So considering minimum beam height 2.7 meter, and this will be this is the sorry, this will be 229. This is unit, all unit will take in meters. Okay, so 0.229 meter into 2.7 meter. This is the height into sorry, thickness into the height. Okay, so into the unit weight. So unit weight of brick is 19 and unit weight of mortar is 20. Approximately we can take 19 around. So that is because plaster is very thin, around 1 or little bit more than 1 inch, 12 mm inside, 15 mm outside. It's like this. So a little bit more than 1 inch. So approximately consider it 19 to be average. And this will be equals to, uh, I'll just calculate this value. So value is 11.7. So let's consider 12 kilo Newton per meter. So this 12 kilonewton per meter will be applied all through, the for all the places where there will be beams, obviously there are walls there, and this 12 kilonewton per meter will be applied. Note that how this calculation is different for different heights, different type of masonry material. If it's brick or if it's something else, then it will be something else. This, if it is double AC block, then the unit weight will be different. The floor to floor height is different, then the calculation will be different. So there is no same load for all the walls. Okay, you have to calculate this each time, and then we need the SBC. So in this project, they didn't give the SBC, didn't conduct any soil test, but from the soil, as per my experience, I saw that it is red soil, and this will lie between 110 to 130 kilonewton per meter square, the SBC, and normal pile foundation will not be required, since they are not going for the. Sometimes you have to, conducting soil test is always the best option, but if the client doesn't do, then nothing you can have. Just you can, best you can do is assume the SBC as per your experience. So I'm going to just take an SBC of here 130 kilonewton per meter cube. This is the SBC which I'm going to take, and depth of foundation for also, since we don't have the soil test report, as per experience, I'm going to provide this depth of foundation as a 1 point. This will provide us 1.5 meters from the NGL. Okay, this we're going to provide. This is very important in stat pro also. We need to consider this, and also in the in the drawings, when you do the drawing part, then also you have to consider this. So depth of foundation is the 1.5 meter from NGL, and then the plinth level we will consider. We also consider the plinth level to be 0.45 meter. So the total height, when you consider the Staad node, it will be 1.5 plus 1.45. This will be 1.95. So This 1.95 will be height from the plinth level to the extreme bottom node, which represents the fixed connection between the column and the footing. So this will be these are the things which we will need. And the building earthquake zone, will consider zone 3 earthquake zone. And zone 3, in the earthquake zone, will not apply wind load. If you have 10-meter less building, wind load is not that compulsory. So zone 3 in the earthquake zone. And sorry, earthquake zone. And this so okay, those zone 3 in earthquake zone, loading which will consider dead load, obviously. So self weight automatically calculated by the software. Then comes the flooring load, which will take 0.5 kilonewton per meter. As per standard, any material they use, marble, tiles, granite, it's covered under that. If you observe 875 part 1. And then we'll apply live load already to 2 kilonewton per meter. Okay. Okay, in the dead load, there is member load also. This for the wall, which you have already calculated. That's done. Live load will consider, and we'll consider the earthquake load. So another load which we could consider is the wind load. So since the building is less than 10 meter, we'll only G+1 building will not consider this. And in some cases, for conservative design, we consider either one of the earthquake or seismic, earthquake load or wind load. But currently, people are considering both the loads also. Okay, so this is the case of this loading. This initial observations of the structure after I got the plan. So I'm trying to demonstrate it right before in front of you. I get this. I obviously before that, I took the amount which I'll take for making this plan as a consultant. So that also, if you want, I'll include that part also. That part I'm leaving out, how to negotiate on the rates and all. So that part I'm leaving out intentionally because there are, many people, different people have different value for the time. So you have to find that how much time you're going to take to, just do this project, and what is the value of your time, what is the market value which you're going to get. We have to be realistic in this case, and obviously this someone will not give very large amount to you for just will making this small building drawings, like for residential projects and all. You'll not get much amount, you'll not get a fixed amount as per square feet also, you'll not get, might not get. But when you work on government projects and projects where vetting is involved, so there will be a good amount of pretty decent amount of money which will be involved. So for that also, I'll make a separate video if you want, but now I'm only skipping the technical parts, and then the work which you need to do, that part, negotiation and all, how to talk with clients and all, this is also very important. But now we are doing with this. The next thing which we'll do, we'll make the video in parts. So next thing which we'll do is that is how to, we'll make the coordinates or in the Staad. So after making the coordinates, we'll do the this all the steps in Staad Pro, then the detailing in the RCDC. So we'll show some ticks of RCDC as well. Then foundation design will also do in the RCDC. We'll design a slab section in MS Excel. Just the largest slab section will take and design in MS Excel, and then is the drawing part. So the entire things which you have patience to watch, you definitely can just watch it, and you can learn. And for any specific doubts, you can just comment below. And if you want personalized training, you can just contact me through my email, and I'll definitely help you and provide you with a coaching session. Okay, so thanks for watching, and keep learning, and we'll meet in the next video where we'll continue this series. Thank you.